Hello everyone, let's solve some trig equations. So here I'm going to say, here's a trig function, I'll tell you what it equals, and then you have to tell me what angles would make that a true statement. If you aren't very comfortable with the unit circle, you need to hit pause and you need to get a unit circle out and you need to study all of the angles and all of the terminal points for all of the points on the unit circle. You cannot, it is impossible for you to be successful if you do not know the unit circle for these problems. So let me start to go through this and say, if the sine of x is positive 1/2, so where is sine positive? Sine is positive in the first quadrant and in the second quadrant. So I'm going to draw some triangles in the first and second quadrant, and I'm going to say if I'm on the unit circle, then sine represents the y value, so we'll make this 1/2 and this 1/2. And then we'll ask ourselves, self, what kind of angle is across from 1/2? And you'd say, oh wait, that's 30 degrees. This is a 30, 60, 90. So these are 30-degree reference angles. Which, in radians, I would say that happens at, this is pi over 6, or x equals 5 pi over 6. Those are in the first and second quadrants. So, got my answers? Cool. If I have my calculator, I can check this, and I can just kind of say, okay, if I take the sine of pi over 6, I should get 1/2. If I take the sine of 5 pi over 6, I should get 1/2. Well, let's bring the calculator up, and let's just see. We've got, make sure you're in radians, so I'll go to radians, and I'm going to just work backwards and see if this works. The sine of pi over 6 is 0.5. Sweet, so I know we did it right. Now, we're going to extend this idea a little bit because it says find all solutions. So I say pi over 6 and 5 pi over 6, those are true, but there's more than that. What if I started at pi over 6 and I went all the way around? So I added 2 pi. So if you add 2 pi, you're going to be in a coterminal point, and that's going to also work. But what I want to say is you can add 2 pi as many times as you want. You can add it or you can subtract it as many times as you want. And the way we say that is we say 2 pi n. And that means like n is any integer. You can add or subtract 2 pi as many times as you want. So n is any integer. If n was 3, that's like saying go around 3 full times. If n was -1, saying start here and go around once the clockwise way, the backwards way. You can do the same thing over here. So plus 2 pi n. And if I try and check that, like let's just see. The sine of pi over 6, I'm just going to say like plus 2 pi, and I'll just say, let's say n is 14 or 11. It just double clicks, so I'll just use 11. So any value that I put right here, I should still get 1/2. So I know I did it right. Cool. Let's try another one. The tangent of x is radical 3, so you should just remember that the tangent of a 60-degree angle is radical 3. And you need to know that tangent is positive when x and y are the same, so that's going to be in the first and third quadrant. So in the first and third quadrant, I'm going to draw a triangle with a 60-degree reference angle. Oh, that's not a 6, be a pen. 60-degree reference angle, or down here, 60-degree reference angle. So that happens at pi over 3 or 4 pi over 3. Now, if we take the idea we said in the last statement, I could say plus 2 pi n plus 2 pi n, and you're right, those are all the solutions, so that is a correct answer. But what I'm going to try and encourage you to do is condense these into as few statements as possible, and this is sort of a thought exercise. But if you notice, these guys are 180 degrees apart. This is 60 and this is 240. So they're 180 degrees apart. I went through the origin with a straight segment. So another way of saying this would be start at pi over 3, but instead of going all the way around, just pick up this guy along the way. Just say add pi, and then add pi, and then add pi, and then add pi. So I'll say plus pi n. That is our like condensed version of the statement. And I want you to try this, but if you can only get here, that's okay. This is just more of a thought experiment. All right, let's try a couple more. So here we don't have cosine by itself, so we first need to get cosine by itself. So I will say the cosine squared of x, add 3, and then I will divide by 4. You can't do anything until you have your trig function isolated. The cosine squared of x is 3/4. Now I'll square root both sides, and this is where you got to be real careful. So the square root of 3 is the square root of 3, and the square root of 4 is 2. But anytime you square root both sides, you got to remember plus or minus, because a negative times a negative is still positive. It still works. So you're actually going to have a bunch more answers because plus or minus work. Now I'm going to draw my triangles and figure out where this happens. So cosine is positive or negative, radical 3 over 2. And that's going to happen when, actually, I kind of off-centered it, but it's plus or minus. So all of the, whoa, that didn't work. All of the 30-degree reference angles, and let me show you why. Cosine is the long leg. So if this is radical 3 over 2, then this would be 60 up here. I don't care about that. I care about the reference angle. The reference angle is 30. So all of the 30-degree reference angles. So if I list them out, I would say x equals pi over 6, and I'll say plus 2 pi n. Or 5 pi over 6 plus 2 pi n. Or 7 pi over 6 plus 2 pi n. Or 11 pi over 6 plus 2 pi n. So that's all 4. If you want to condense those, let's not get too fancy. Let's condense them maybe into 2 statements. If you start at pi over 6, that gets you here. You could add pi, so plus pi n. That takes care of those 2. Or you could start at 5 pi over 6 and also add pi n. If you start at 5 pi over 6, that's here. And then pi will get you here, and then you can keep going. So that's a condensed version. You could probably condense it into 1. Like, what would be a crazy way of saying this? Let's see. Pi. I don't know. Well, I'm not gonna worry about it too much, but there's some fun things you can try to try and make this one statement, like plus or minus pi over 6 from here or there. But let's just try some practice problems. I want you to isolate the trig function, so you have to do that first, and then tell me what angles give you that ratio. So this is where, if you're practicing, you should pause this and you should work them out. It doesn't do you any good to just sit here and watch me do problems. So pause it, give it a shot, see how you're doing, and then if you're not figuring it out, see if I can help you. So hit pause. And we're back. We're going to get cosine by itself, so we will subtract 1. And now I will think about where cosine is negative 1. So cosine is the x, and x is negative 1 over here. That's negative 1 comma 0. So that happens at pi radians, and we'll say plus 2 pi n. So x equals pi plus 2 pi n. If you add 1, you get 2 sine of x is 1. If I divide by 2, I get the sine of x is 1/2. So isolate your sine. We've already done this one. Sine is positive in the first and in the second quadrant. It looks terrible. First quadrant, second quadrant. You want the y values to be 1/2, which means you were talking about 30-degree reference angles. So that happens at pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n. You can't condense those because they're not pi radians apart from each other. They're not across from each other. Cosine of x, you would add 1 and then divide by radical 2. Then you need to rationalize that because we don't deal with that, and that would be radical 2 over 2. So cosine is positive radical 2 over 2. I know those are going to be 45-degree reference angles, and I know that cosine is positive where x is positive on the right side. So 45-degree reference angles puts you at pi over 4 plus 2 pi n, or 7 pi over 4 plus 2 pi n. Let's get fancy on this one. I noticed that since this is plus or minus 45 degrees, a fancy way of saying this would be plus or minus pi over 4. So either add pi over 4 or subtract pi over 4 and then add 2 pi n. That'll do it. It's kind of fun. Let's check that one just to see. I'm going to take my calculator and I'm going to make this ridiculous. Oops. Let's say radical 2 times the cosine of, and I'll just say negative pi over 4 plus 2 pi, and I'll say like times negative 6. I'm just trying to make it silly. I think this should still work. I think I should still get 0. Oh, I got to do minus 1. Okay, so radical 2 cosine x minus 1, I should get 0. Look at that. I can do that with any n. Any number I put right there should still work. So that's kind of fun. Try a couple more. Okay, these are squared. So we're going to have to get cosine squared by itself. So add 1 and divide by 4. Then square root both sides, which the square root of 1 is 1. The square root of 4 is 2. And if you don't remember plus or minus, you only have half the answers. So let's see. Where is cosine positive 1/2? That is positive 1/2 is up here. 60-degree reference angles. but we're doing plus or minus, so all of the 60-degree reference angles. That's because the long leg is radical 3 over 2, and the short leg is 1/2. So how we say this? Let's list them: pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n. We could say 4 pi over 3 plus 2 pi n, or we could say 5 pi over 3 plus 2 pi n. So 1, 2, that's 3, 4, 5. 1, 2, 4, 5. Those are all the pi over 3s. That's a 3. Can you condense that? We can condense it a little bit if you want. We could say start at pi over 3 and add pi n. So pi over 3 plus pi n, or 2 pi over 3 plus pi n. All right, let's see if we can get crazy with it. Can I make this one statement? Plus or minus pi over 3. So either plus pi over 3 or minus pi over 3 plus pi n. So there's my super condensed version. Here's all 4 in red. That's cool. Here's green. You're like, yeah, you're pretty cool. But then this one, plus or minus pi over 3. So start here and you can go add pi, or from here you can add pi. So that's like the most condensed version. Again, I'm not concerned if you can get all of these condensed versions, but I think you should try it. It's going to make you better at going through this process. Number 8, let's see. Cosine squared x, you would add 1 and divide by 2, square root both sides, and then that means cosine is plus or minus the square root of 1 is 1, radical 2, so we'll rationalize and get radical 2 over 2. So all of the plus or minuses, plus or minus radical 2, so all the 45-degree reference angles in both quadrants. So that's 45 degrees, all of them in the middle. So all the 45-degree reference angles, I would say that's pi over 4 plus 2 pi n, or let's see, 1 pi over 2, this is 3 pi over 4 plus 2 pi n, 4 pi over 4, 5 pi over 4 plus 2 pi n, or this is 6, 7 pi over 4 plus 2 pi n. So there's listing them all out. Let's see how we can condense it. All right, here's like your intermediate mode. You would say start at pi over 4 and add pi n. That'll do it. Or start at 3 pi over 4 and add pi n. This is pi over 4 plus pi n, so that's the first two. And then 3 pi over 4 plus pi n gets you the other two. Now, let's get crazy with it and see. If these are 45 degrees, then that's also 45 degrees, which means this is 45 degrees. So these are right angles. These are 90 degrees apart. So we could say start at pi over 4 and then add 90 degrees as many times as you want, which is pi over 2 radians. So pi over 4 plus pi over 2n is the most condensed. So you got your like, oh, I'm cool, I get the idea. Or I'm pretty cool, or like, I'm a rock star. So pi over 4 plus pi over 2n. One more, we'll say, actually, I'm going to add tangent squared, so it's positive. I just like for it to be positive. And then when I square root, I get plus or minus 1 is the tangent of x. So where is tangent of x? 1. Or negative 1. That's all the 45. This is the same answer. This 8 and 12 have the same answer. So I'm just going to say I'm going to be like, hey, it's this. We did it. Okay, so I'm sure on your paper you have the ability to copy and paste, right? Well, I can, so cool for me. These are the same answers, though. All right, these are sort of like our basic ones. We haven't done any factoring yet or anything too fancy, but you should be able to do this pretty well. Make sure you've got your assignments done, and while you're at it, maybe hit that like and subscribe button.